This is our presentation on movie rating classification by Nikhil, Joyce, myself, Nikhil, and John. So a little bit of our motivation for this project is kind of looking at the lack of social interaction we've had. We wanted to focus on something in the movie realm. So we want to look at predicting accurate critic ratings, what features would be helpful for producers and directors when deciding how to maximize their film success. So we looked at kind of Rotten Tomatoes and a little bit about how this website works is their ratings, positive is 3.5 and above. And if you have above a 75% of your ratings above that number, then you are certified fresh for movie. And so these reviews come from a bunch of critics that Rotten Tomatoes has had to approve prior.
Next, I'll talk a little bit about our data preparation process. We used a data set from Kaggle from TNDB, and we first dropped useless columns and then checked remaining columns to ensure that columns were the right data type, like distribution, or one that made sense, and deleted rows with inaccurate data. Then I did a little bit of feature engineering by creating different columns for month, day, and year from the release date feature, and then further clean text columns. We also looked at different features, like numerical features, and visualized them to kind of get a better understanding of the data.
Yeah, so we wanted to add another feature that was kind of like an NLP feature that where we built a logistic regression model that determines if a given review is positive or negative. And so we need two things for this. One is a web scraper to actually get all the reviews, and another is a logistic regression model. And so we use a web scraper. Specifically, we use Beautiful Soup to get text from rogerebert.com, and we were able to build URLs, and we were able to get reviews for about 41% of the movies in the data set, which still left us with 4,100 movies, which is pretty good. So we decided to go with that. Then we cleaned the reviews by removing punctuation, HTML tags, and lowercase all the words. And then we built a logistic regression model using a training and test data set that we found online. It had two columns, which was the one which had an actual review, and the other if it's positive or negative. And we were able to get a 93% test accuracy. And then so I applied the model onto all the web scrape movie reviews and then add that as a feature to the data set. And finally, Simone built a Rotten Tomatoes score scraper that basically pulled audience and critic scores from movies on Rotten Tomatoes.
Moving on to the analytics models, we first did NLP text cleaning on the final data set before use for modeling. First, we removed spaces from columns that had full names and proper nouns to treat all of those as one word. We then extracted each word in the columns that had a list and removed punctuation and digits so that we could get it into its proper form. After that, we tokenized to remove stop words and perform stemming. And after detokenization, we selected words that met certain frequency requirements so that we could get sizes of data frames that we felt were appropriate. And we also process each column with text independently. So for example, if one word appears in both keyword and overview, it's treated differently. Finally, we combined all of these decision tree matrices into a final data frame with around 650 features. We first attempted to do regression modeling, but the R-squared were very low for all the models, so we decided to focus more on classification. These are the different models that we attempted with a threshold of 75 as the rating to see if it was certified fresh or not. Gradient boosting classification performed the best with the highest accuracy and true positive rates, but random forest classification also performed well with low false positive rates and high precision.
To further improve the model, we then created an ensemble. So we use the voting classifier to create a simple combination ensemble that uses a hard majority vote of successful individual model predictions to see whether a movie is certified fresh or not. So this resulted in higher accuracy, very low false positive rate, and high precision. So at this point, we have a pretty decent model for predicting whether or not a movie will have a certified fresh rating on Rotten Tomatoes. And before the final report, hope to iterate on this with different ensembles to improve results further.
When working on this project, our goal was to understand what goes into high critic ratings. Creating a successful model has given some good insights into what makes a good movie in the eyes of critics. Based on all of our models and analysis, we found that certain features were important to higher ratings, such as cast, production companies, and genre. These features are not only critical to higher ratings for these movies, but they also show their inherent qualities that lead to higher ratings, which indicates some bias. Using our model, people can predict how a movie will get rated based on their specific feature. Our project can also help film producers identify the characteristics of past successful movies in terms of ratings for critics and implement those in their future productions. And that's all, so thank you.